All right, so for this 2.4, we're going to split up into a couple sections. But we are basically going to be talking about first combining like terms and then finishing with the distributive property. So our focus for this video is going to be like terms, what they are, and how we combine them. First of all, we got to talk about a coefficient. All right, and if you're not sure what terms are, but we've been separating terms within problems, so you guys should have had that that background coming into this. So the first thing we got to talk about is what a coefficient is. All right, a coefficient is a number that is being multiplied by a variable. Or being multiplied to a variable. All right, so write that down as your definition. Now we have some examples down here. In this term, 3x, the 3 is the coefficient. That is a number that we see that is being multiplied by the x. In this particular problem, x and y, and again, a term is a number or variable or a number multiplied by various variables. -4 would be the coefficient. Now here's where sometimes it gets confusing, but that's why I want to tackle this now. I'm going to write down z as well, not just -z. But in this case, when you don't see the actual number being multiplied by the variable, we assume that it's a 1. All right. So in this particular example, we have a -z or a -1z. So -z is the same as -1z. So in this case, our coefficient is -1. If it's just a positive z, then our coefficient would be +1. All right, so the first step when we're leading to combining like terms is one, being able to identify just that coefficient. The second part is to recognize which parts are like terms and which are not. Like terms have the same variable factors. All right, so it could be just an x and an x. These would be considered like terms. It could be an x and a y within that term, and those will be like terms as well. But they also need to be to the same exponent. So a x to the third and an x to the third here means that these two terms are alike. If I have a counterexample, 3x and 3x to the third, these would not be like terms because this x is not to the third power, or this one has an exponent. So like terms have to have the same stuff basically after the coefficient to be considered alike, which includes the exponents. Now, once we can identify one, the coefficient, and that they are like terms, mathematically we are allowed to combine the like terms. All right, so like terms can be combined by adding or subtracting the coefficient. All right, so write that in there, coefficient, which is this right here. All right, so we can add and subtract the coefficient. Did I spell that right? Once we can identify those. So when I look at these two problems in these examples right here, I have a 3x and a 6x. Now again, we've talked about looking at a problem in terms of terms. I have a 3x and a positive 6x. So the way I want to think of this as 3 plus 6, and that equals 9, and then our variable term, or our variable goes with that term. All right, same thing over here. I have a -3xy, a positive 12xy. So all I have to think about this is -3 plus 12. So I could type that into my calculator, and I get 9, and then your xy at the end. All right, we're going to practice this on the next page with multiple examples so we can run through how we do that. This part, it's a little out of place, but we'll refer to it in the next couple of days. Whenever we have a term or we have a parentheses in the problem, we refer to this as the quantity of. All right, so you can write that in there, but we're going to touch more on this later in the part 2 of this section. So it represents numbers inside the grouping symbol. So if I were to say, for example, 3 times the quantity of x plus 4, that's how I would read that. All right, so for these examples, and then again going into the next page here where we have more than just two terms in there, we're going to decipher how to combine those. So if I look at all of these all have like terms in the problem. So I have a 7y and I have a positive 6y. So since they both have that variable term, all I have to do is do 6 plus 7, and that will give me my answer. So 6 plus 7 is 13, and then include that y, because that is how we would combine them, right? So you have to include that variable term with it. For sample B, I have two terms. I have a 3t and I have a negative t, but remember, we think of this as negative 1, right, when there's no number there. So I have to think of this as 3 minus 1, and that's going to be 2, and then include that t in your final answer. So 3t minus 1t is 2t. All right, over here, again, we have to the third power, so these are still like terms, right? And I look at just the coefficient, negative 9, negative 3. So I'm adding a negative 3 plus a negative, or negative 9 plus negative 3, or negative 9 minus 3, however you want to think of it. The value of the terms are the same, so we add them and keep the common sign, so that would be negative 11, and then keep that w to the third with the problem, right? Over here, we have an 8d plus a 1d. Think of that as a 1. It's not going to be listed in anything you see. It will always just be assumed. 8 plus 1 is 9, and then we include the d right there. Okay. So let's take a look at the next page. I want you guys to kind of work on some of these on your own, but pause. We're going to go through the first two, but then pause, try them, and this is what we're going to cover for today. So when we look at multiple problems, I'm going to show you a couple ways that we can kind of look at these and how to do them. We're going to simplify by combining the like terms. So in problem 1, we have 3 terms. So when we box the terms or separate them, what I like to do is kind of just start with the first one, a 10x, and then I'm going to look for other terms that contain that same variable. The positive 3y does not, but the positive 5x does. So these two are considered like terms, and I can add them then, or I can combine them. I like to use the term combined. So I have a 10x plus 5x. 10 plus 5 is 15x, all right? And then whatever's left over, because there's only one term left, I will bring that term down into the problem. So plus 3y. So now I took 3 terms, combined the 2 like terms into one, and then I have that one term left over that I can't combine with anything because they don't have the same variable. So the final answer here would be 15x plus 3y. All right, so looking at number 2. Again, we have 4 terms. A positive 2x squared, a positive 7y, a positive 4x, and a positive 6x squared. All right, now looking at these, I want to start with one of the terms. So I have a positive 2x squared. Now I'm looking for other x squareds within the problem, and this positive 6x, and remember, include that positive, is part of that. So now I can add 2 and 6, because they're both positives, combine those terms, and we get 8. And then have that x squared as part of the problem. Now I have 2 other terms within this problem. The next term I'm focusing on is this positive 7y. Note that the final term is not a y, it's actually an x, so I can't do anything with that. So I'm just going to bring that down in the problem. All right, and then here, this is my last term that's left over, so I can bring that down as well. So this would be my simplified answer after combining all of the like terms. All right, go ahead and try the next couple problems and see how you do with these. All right, hopefully you paused it and looked at it, see how we do. So if I look at this problem, my first term is a 9y, and there is a positive 3y that goes with it. So 9 plus 3 would be 12y. And then I have this 5x left over, so just bring down that positive 5x. Remember, if we're writing it next to another term, we have to indicate that value. So I can't just write 12y 5x, right? Make sure you're separating terms with either a plus or a minus based on what their value is. All right, over here, I have a 2y squared, I'm looking for another y squared in here, and I have one right here, a positive 6y squared. So I have 2 plus 6, which would be 8y squared. Now I go to my next term that I see a positive 7y. And note here that this has a y as well, so these are considered like terms. So I have a positive 7, positive 4. I can add those together. I get 11, a positive 11, and then we put that y with it again. All right, let's go ahead and work down the list a little bit. Again, if you haven't done this on your own and tried it, pause it and give it a go. All right, so here I have an 8x, and I look for another term that has just an x in it, and I have a negative 2x here. So then I have positive 8, negative 2. 8 minus 2 is 6, and then we have that x with it. The one that's left over is a 1y, so I can just bring that down. I can't combine that with anything, and that's my final answer. All right, over here, I look here, I have an x squared, and I look for another x squared. So I have a 9x squared and remember that's a 1. 9 plus 1 is 10. So we have our 10x squared. Now I look for my other like terms here. Only 2 left, so it's pretty obvious. 7y and a negative 4y. So again, in your calculator, you can just do 7 minus 4. That would be positive 3, and then include that y. All right, over in this problem, we have a 14x. I like to start there. All right, look for other terms that have just the x in it. So here's a negative 3x. And I also have a positive 3x. So in this example, I have 3 terms that are in there. So I can just add those together. 14 minus 3 plus 3. That's what you could put in your calculator. If you put that in, you're going to get 14. And then include that x. And then our 2 left over, we have a 2y and a negative y. Remember, that is a negative 1. So 2 minus 1 is 1. So that would be a positive y. Or you could put 1y. Either of those are good. Again, you're going to see answers like this without that 1 listed. But if you put the 1, that works as well. All right, so take your time with these. Make sure you're looking at the value of the coefficient and that you're looking at all the other stuff that goes along with that term to make sure they have the same variables and to the same exponent so you know which ones are alike.